Good day. In last video, we discussed about replacement model with the model 1 procedure. Today, we can move to model 2 procedure. From model 2 procedure, how can we solve the replacement model problem? In model 1, we are not considering about rate of interest. Let's see how can we solve the replacement problem with the model 2. The replacement of item that deteriorate with time, considering time value of money. So the model 2 concentrates about the time value of money. The model 2 follows the following procedure. In model 1, we not pay the interest for the money what we are invested on the equipment. If the effect of time value of money is to be taken into account, the analysis must be based on equipment cost. So, the present worth value is played in model 2. So, for identifying the present worth value, the following formula is utilized. The formula is the present worth of a rupee to be spent after a year is denoted by capital V. Capital V is equal to 1 divided by 1 plus R. From this, we can estimate the present worth of expenditure, which can be solved by P of n is equal to capital M plus capital R1 plus R2 into V plus R3 V square plus up to V power n minus 1 into Rn. Likewise, we may utilize the formula for identifying the present worth of expenditure. Here, in this formula, there are a lot of terms available. The terms are capital M. Capital M means purchase price of an equipment or item. And then capital Rn. Generally, Rn is called as running cost in year N. If I utilize R1 means running cost in year 1. If I utilize R2 means running cost in year 2. Likewise, I can categorize the R value. And then here in a capital V discount rate formula has 1 divided by 1 plus R. Here what is R? R means rate of interest. If I assume an interest of 10 percentage means rupees 100 per day will amount to rupees 110 after 1 year, which is the assumptions that are involved in interest. So how can we solve the problem with the consideration of rate of interest? Let's see. For understanding the model 2 in replacement problem, the following problem is used for replacement model 2. The initial cost of part is rupees 15,000 and maintenance or running cost for different years. In this problem, there is running cost only available for different years are given below as like first year consumes 2,500, second year consumes rupees 3,000, third year consumes rupees 4,000, fourth year consumes rupees 5,000 and fifth year consumes rupees 6,500. Finally, the seventh year consumes rupees 10,000. Here, the question is, what is the replacement policy to be adopted if the capital is worth 10 percentage and no salvage value? So, this problem can be solved only by present worth method, which is model 2, because in this problem we are having 10 percentage of interest value. So, how can we solve? Let's see the solution. First step, we can formulate in the red color zone. I can replicate the same whatever the data available with the problem. I replicate the same thing with the year and the running cost. Other than that, the blue color is available. In that first column has the data as like v power n minus 1. Here, how can we identify? For identifying the v power n minus 1, first we should identify v value. How can I estimate the v? So the formula utilized is equal to v is equal to 1 divided by 1 plus r. In this problem, we are having 10 percentage. So r value is 10 percentage. So that I convert that into 0.1. 1 divided by 1 plus 0.1, because R value is 10 percentage. If I convert that rate of interest to normal value, which is 0.10. So I substitute the same value it into discount rate equation 1 divided by 1 plus 0.10 I got. From this I can get 0.9090. Likewise I got. For assigning this value it into the table, the first year I can't able to utilize the same value as like 0.9090 because the formula is v power n minus 1. Here what is n? The year value is n. So according to the first serial number, the year is 1. So v power n minus 1 is equal to v power 1 minus 1 because the year is 1. I substitute the value in terms of n is equal to 1, so that v power 1 minus 1. Here I got the v value is 0.9090, so that I substitute 0.9090 hit power 0 as like I can get is equal to 1, so that I can substitute one value here. For example, I consider the second serial number means the v value is 0.9090, the same value I utilized because I got constant v value for all the years. After that, the power value n, I replace 1 with the 2 n because the second year v power 2 minus 1, so that I got 0.9090 power 1, which is equal to 0.9090, so that I substitute 0.9090 here. After that, the next column is associated with the multiplication of the product of running cost into v power n minus 1, so that I can multiply the both the columns with each other. 2500 into 1, I can get 2500. The next column used to find the summation of every year. For first year I can replicate the same 2500 here, but in the second year I can add the first year value and the second year value, which means 2500 plus 2727. From this I can get 5227. After that, if I consider third year means I add both the things with each other, which means 2500 plus 2727 plus 3304.8. From this I can get 8531.8. After that I move to next. The same procedure you followed for other year also, which means fourth year, fifth year, sixth year, seventh year also. So the same procedure you follow, so that I move to next column. The next column is present worth method. In that, the initial cost plus summation of v power n minus 1 into Rn. Already I found v power n minus 1 into Rn summation value. If now I can add this value into investment cost, which is m, so that 15,000 is available with our problem. Initial cost of part is 15,000, so that 15,000 plus 2500 I can get 17,500. After that I move to next value, which means m value is the same 15,000, but I can add with the second year value, which means 5227, which means I can get 20,227. If I consider third year means I add 15,000 plus 8,531. From this I can get 23,531.8. Likewise, you follow the same procedure for another years also, which means fourth year, fifth year, sixth year and seventh year. Finally, I create another table column which associated with the summation of v power n minus 1, so that I add 1. Okay, here the value is 1. According to the second year, I can add 1 with the 0.9090. From this I can get 1.9090. And for third year, 1 plus 0.9090 plus 0.8262. From this I can get 2.7352. If I go for fourth year means I add first year value 1, second year value 0.9090, third year value is 0.8262 and the fourth year value is 0.7510. From this addition I can get 4.1689. Likewise I may get. Then I can move to last column, which means final column. From this only we can identify which year I can replace the machine. So that carefully we calculate the final column is W of n is equal to present worth, which means P of n divided by summation of V power n minus 1. So for considering the first year, P of n is equal to 17,500. Okay, and the corresponding sigma power V power n minus 1 value is 1. So if I divide both the things with each other, means 17,500 divided by 1, I can get 17,500. Then next year the same procedure is followed, which means the 20,227 divided by 1.9090. From this I can get 10,595.59. For considering third year, I can utilize P of n value is 23,531.8 divided by 2.7352. From this I can get 8,603.31. Likewise, I follow for all the years. In fourth year, I mean fifth year, I can get 7,609.76. Why I mark red color? Yes, you can see the fourth year 7,827 available, and fifth year 7,609 is available. After that you see the sixth year 7,660.32, I mean 32. Likewise, the WN value is increased, so that the fixed annual installment given by the last column is minimum at fifth year, which is 7,609.76. So it is optimal to replace the machine after 5 years. So the reason only here I put red color box. From this we can aware when we should replace the equipment with the consideration of money as the time. Okay, if we consider the rate of interest with the problem, means we can solve the problem with replacement model with this step, replacement problem with this model 2. Thank you all. If you are having any doubts, you may ask through comment box. Thank you all.